Hello, this is question 3A of the December mock paper. Question 3A shows the stress against strain graph for a metal X up to its breaking point. For 3AI, you need to state the physical properties of this metal. As the gradient of this line is constant, it shows that this material is brittle and is also elastic. But remember, in this question you need to be as specific as possible and always use the keywords as it states underneath the question. Simply for question 3I, you need to sketch a graph for a ductile material that has a larger Young modulus than the metal X. So for this, to prove that it's got a larger Young modulus, you need to have a steeper gradient and less strain, but it also undergoes plastic deformation as it is a ductile material. For question 3B, it shows a stationary cable car. For question 3I, you need to calculate the strain experienced by the cable. So if we start off with the equation Young modulus equals stress over strain, we can simply take strain over to the left hand side and take Young modulus over to the right hand side, which gives us the equation strain equals stress over Young modulus, which I'll highlight here. So strain equals 1.8 times 10 to the 7 divided by 2.0 times 10 to the 11, which gives us the answer 9.0 times 10 to the minus 5. For question 3I, you need to calculate the tension T in the cable. Tension is equal to the force. So if we start off with the equation stress equals force over cross-sectional area, we can simply take force to the left and take stress over to the right, which gives us the equation force is equal to stress over cross-sectional area. But first we need to calculate the cross-sectional area, which is pi outside the brackets times 2.6 times 10 to the minus 2 squared, which gives us the answer 2.12 times 10 to the minus 3. So if we simply sub these values into the equation, we have F equals 1.8 times 10 to the 7 times 2.12 times 10 to the minus 3, which gives us 38,160, which can be simplified to 3.8 times 10 to the 4 newtons. Question 3II, we need to calculate the weight. If we go back up to the cable, we can see that there's two cables, two different angles. So if we create the equation 2t sin 12 is equal to the weight, we do weight is equal to 2 times 3.8 times 10 to the 4 times sin 12. Weight equals 1.6 times 10 to the 4. But there's an alternative way to tackle this question. You can simply calculate the vertical components of this diagram here and then just simply add them together, which is quite simple. But yeah, that's how you answer question 3 on the December mock paper.